my name is Jordan, and before we get started, I'd like to do something a little bit different because I have kind of a confession to make. This is my first LastCon, so let's get started. So we are here to scan IPv4 for free data and free shells. Hopefully that's the talk you came to. If it's not the one you wanted, just consider it destiny. It's probably a good thing that you're here. So we'll get started with a little bit about me. My name is Jordan. I am an R&D engineer at Duo Security. So part of my job is to think, what do we have 8, 10, 12 months down the line? What kind of problems do we need to solve, and can we solve those in an elegant way? So in my spare time, security is my hobby. I'm a security researcher. I publish everything to a personal blog, and I'm also a huge fan of open source development. I firmly believe that a lot of the best security tools do come from open source. So I publish a few myself, and I stay very active on GitHub, so feel free to check out some of my projects there. And I also just realized that I apparently only own one shirt. I promise I didn't do that intentionally. That was I didn't take that picture 5 minutes ago. So really quick, let's have a quick shameless plug. These are some of the projects that are made on my own personal time. So you'll find these out on GitHub. The first is Dumpmon. You may have seen it's a Twitter bot that crawls Pastebin and other pasting sites for password dumps. So if it finds a valid password dump or other sensitive information, it'll aggregate it and then tweet it out to kind of bring attention to it. I also wrote an email library for the Go programming language. Are there any Go programmers in here? It's kind of an up and coming. You'll get there. That was kind of a prerequisite for the next one, which was GoFish. It's a phishing framework written in Go. It's an open source phishing framework. It kind of helps you measure your exposure to phishing. And finally, the reason that I mentioned these projects at all is for the last one, Elastic Honey. It was kind of a small project that I made on a per-need basis, and we'll see what that means here in a few minutes. But it's what I would call kind of a low to medium interaction honeypot for Elasticsearch. So attackers will connect to the honeypot. They can try to do what attackers do. They'll try to exploit what they think is an Elasticsearch instance. It'll record everything about it, and it has the option to log things locally. It also has the option to send things to a web server or, ironically, to another real Elasticsearch instance. But let's take a step back. Why are we here? Today, we're going to talk about data. We're going to talk about a lot of data. We're going to talk about systems. But more specifically, we're going to talk about some hip ways to store data. We're going to talk about some of the the cool new hip things people are doing to make their data access fast. And then we're going to talk about what happens whenever you realize what a grave mistake you made using some of those things the wrong way. And we'll see what we see on the internet in terms of exposed data. We'll also take a look at vulnerable systems. So data is one side of the story, but we're going to look at the systems themselves and really measure out the problem of how big this idea of exposed services is across IPv4. And then we're going to look at it kind of holistically, and we're going to talk about why is this happening? Is there some kind of a root cause that we can nail down that's causing this problem to occur? And finally, we always like to end things with, what can we do about it? How do we make this better? How can we protect ourselves and our own organizations from having our own data exposed and having our own systems made vulnerable? So to get started, real quick question. How many people in here have ever made a web app, just in general? Even if it's just a toy project, something, a lot of people here, right? It's always funny because the first thing that I hear from people whenever they make a web app is, how do I make it fast? They want it to be snappy. I spend way too much time on Reddit, on different subreddits where people come in, they say, hey, I'm starting up a new company. I need a programming stack because I need my web application to be fast. I'm planning on scaling to millions of users. Now, of course, that's a bigger problem than making a web app fast, but this is a big need. People want their applications to be quick and easy. Now, granted, we all know that the real reason web apps aren't fast in general is because you're using Node, and JavaScript was never meant to be a server-side language. But all that aside, let's look at the core problem that people are mostly, I may have offended some people. Let's look at the core problem what about access to memory? Usually that's what people mean whenever they want their web app to feel fast. I have a lot of data. I need to load it quickly. I need to be able to manipulate it and query it and search on it quickly and in interesting ways. So that's the part of my web application that I want to be quick and I want to be snappy. So this is a big need, and there's been a lot of solutions and key things to look at it. Depending on who you talk to, they'll recommend all sorts of different options. It's kind of like a pre-workout. The shinier it is, you have no idea what's in it, but you're told it's the best. You got to go with it. So there's two kind of ways that we're seeing the industry move in terms of storing data. The first is key value stores. These store data in memory, generally, and they are just that. They're meant to be simple. They're meant for me to be able to say, here's some kind of identifier, which is a key. Let's call it foo. Then I say, I want to store this piece of data, a simple piece of data called bar, according to that key. And then I can do lookups over time. The benefit of having something be so simple and being stored in memory is that I can use it for things like caching. If I have data that's accessed over and over and over again, like let's say a new product comes out and I'm an e-commerce site. That product is getting hit by everyone who comes to my site. Maybe I want to cache the content of that page, and it's even quicker so I don't have to go to the database every time someone wants to access the details for that product. That's an example of what a key value store can be used for. The other one is temporary data. So a lot of people may use something like a key value store for storing sessions. So storing user state, session cookies. It's a very valid use case because the key is pretty basic. You can have it be your user ID, and then the value could be the session token or session cookie or reverse. So that's key value stores. The other way is NoSQL databases. These are more on the persistent side of things. These aren't meant to be more temporary data like the key value stores. These store data on disk, and they do what's kind of called document storage. So it seems like the general idea was that we got so tired of specifying schema and having to deal with all these pesky tables and columns that we just said, let's just throw JSON at the whole thing, and let's call it document storage, and we'll go about our day. And so that's the way that NoSQL databases work. A lot of them are schema lists. You can just store the data that you want in them. And these are your actual application data. These are your product details. These are your user profile information. These are anything that your application needs to store for long periods of time. NoSQL is a way to go for this technology. So what should you use? You go to Reddit, Stack Overflow, and you say, hey, I want to make a startup. I need my web app to be fast. What technology should I use? And you're going to have 10 opinions if you talk to 2 people, right? Because it all depends on, like any question in our entire industry, the answer is it depends. It depends on what you need. There's no real clear-cut answer. But here are some examples. On the left, we have Redis and Memcached. Have anyone heard of these technologies before? Okay, good. So that's a good start because we're going to talk about them. How about any of these on the right-hand side for NoSQL databases? Mongo, anybody? And then there's a few others, CouchDB, Cassandra. I see a few hands getting raised. And then some people will get mad at me for including Elasticsearch because they're going to say it's a full-text search engine. It's not a NoSQL database. It's my talk, so for this talk, it's a NoSQL database. So, let's be real here. What should you actually use? And we all know the real answer is just whatever is on the front page of Hacker News that day. I call it whatever the heck.js. It's probably open source that day. It has like 2,000 stars. You can trust it. It's the best. But for this talk, we're going to talk about these technologies. So we're going to go through them, and we're going to kind of figure out how popular are they, because these are, according to the one website I looked at, the most popular technologies being used today. So let's take a step back and let's talk about the problem. Why are we here? What are we talking about? What's the purpose of this talk? The problem is twofold. The first is that there's a ton of sensitive data being exposed to the internet, probably not intentionally. Or if it's intentionally, that's an even bigger problem, right? The second part of the problem is that thousands of systems are vulnerable. So we're going to look across the entire IPv4 space, and we're going to say how bad are we at patching software? how exposed are we in terms of vulnerabilities, and not the kind of vulnerabilities like a logout CSRF vulnerability or a reflected cross-site scripting that affects nobody. These are remote code execution vulnerabilities, unauthenticated remote code execution vulnerabilities. If you were in, let's say you're on the red team, there's 4 words that just make your day, and those are it. Unauthenticated remote code execution, because you have to do nothing to get access to the host, right? It's a payday, and we'll talk a little bit more about what these look like here in a few minutes. But first, let's talk about the first part of the problem, which is that sensitive data is exposed. This is what 2015 and 2016 have seemed like recently if you've been watching the news. I kind of call 2015 the year of the voter databases, right? Because it seemed like so often there was a new voter registration database being exposed by some other company. And granted, some of this is public information or information that you can pay for. But there's a problem whenever those kind of details are just left out in the open unintentionally. So this is an example of what that landscape looked like. I'm not going to go through all of these, but you can see, and these aren't all of them, by the way. These are just, I wanted to fit it in a slide so you could read it. These are some of the bigger ones that we saw in 2015, and there was a single guy named Chris Vickery who did a lot of really good research in terms of looking for exposed Mongo databases and looking for exposed, similar to what we're talking about today. And what he found were these exposed information. So you have things like the voter records we talked about, the Modern Business Solutions, which is their entire clientele. You have the MacKeeper, which is a lot of their user information. So a lot of sensitive exposed databases, and it just seemed like it was MongoDB all over the place. You just couldn't get away from it, right? It was a payday anytime you wanted to look for it. So all that being said, what kind of data is exposed? What are we looking at here? And so on the right, you'll notice that you can't read that picture, and that's on purpose. That's because there are so many rows in that schema that I can't list them all out. In a nutshell, you can just envision it as everything about you is in there and being exposed. But here's some of the highlights. Personal information is huge. These are things like your standard PI, name, address, email, phone number, date of birth. In some cases, in one voter registration, your religious affiliation, what party you voted for, your history of voting. A lot of this information that you don't want released in a mass format that's so easy to obtain, right? And then you have the other side of the spectrum, which isn't necessarily personal information, but it's application data. So you have, like I said in Mongo, people store their profile information there. That includes your username, that includes your email address, and that includes your hashed password. So if this is left out on the internet, I don't have to go find some kind of, if it's relational, I don't have to go find some SQL injection or some, Mongo JavaScript injection or something crazy like that to go dump the database. I can use the standard tools to connect to it and just download it. It's public, it's out there, there's no authentication for it. So all that being said, how much data are we talking about? And it really kind of depends on who you ask. There's 2 organizations and 2 kind of commercial offerings that have looked at this kind of data in the past. The first is Shodan. Has anyone heard of Shodan before? It's going to be pretty popular, right? It's a powerful tool. For those of you who haven't heard about it, it's basically, think of it like a search engine for devices. So you can search through metadata about a device, like the banner that it returns whenever you connect to a service. So Shodan's done some work in this area, and the other is one called Binary Edge. They're kind of an up-and-coming firm. They have a product similar to Shodan, but I kind of look at it like Shodan on steroids, because it does a lot of correlation on the back end. It does a lot of additional metadata gathering, but it's a more commercial tool that costs money to access their results. So all that being said, it depends on who you ask in terms of how much data they found. And not only that, but this stuff changes every day. People expose new services, or they delete data, or they add data. You're never going to be able to pinpoint in time just how much data is out there and keep it accurate. So looking at the 2 different sides of the story, kind of averaging it out, it seems like, in a nutshell, we're looking at the amount of data that is stored in these devices is around 700 terabytes. And some of this data is sensitive, sure, and some of it's not. Some of it's just generic test data or stuff you don't care about. But it's clear that there's a big problem. It's clear that there's a lot of data to sift through. It's clear that there's a lot of data exposed, and there's something that needs to be done about it. So the burning question is, what do we mean by exposed? What qualifies as exposed data in our case? There's a few things. The first is a service listening on all interfaces. So not just bound to localhost, I can reach it from across the internet if I want to. The second is that there's no authentication. It's just left out. I don't have to know any credentials. I don't have to know a password to access this device. The third is that it's storing sensitive information. That's optional, right? And then it could also be running a vulnerable version of software. And the last is the one that kills me. None of this software needs to be run as root. It doesn't. We run it as root because it's easy, right? It's the easy thing to do. It works, and so then we leave it. But then they're leaving an exposed service that's potentially vulnerable to unauthenticated remote code execution as root. So at that point, it's game over. At that point, the attacker completely owns the box, and you have no choice if you want to remediate the problem, then wipe it. Because at that point, you can't trust a thing on that box. So that's what we mean by exposed. And if you do all that, as the picture suggests, you will have a bad time. So let's look at a few examples. Let's go through some of this technology. Let's talk about some of the ways that we, if we wanted to be attackers, could expose every single piece of data in these software. Let's start with Mongo. Anytime I talk about accessing data, my first thought is, can I just bulk export the stuff, right? If I'm an attacker and I just want to download the entire database, do they give me tools to do that? And the good news is that backups are a real problem. And people like making backups, and so they need tools to make backups. Well, that's exactly the tool that I'm going to use to download all their data, because that's what's proven to work. That's its job. So that's going to be the first thing that I look for. And for Mongo, they have a great tool called MongoDump. It's just a command line tool. It makes just that. It's a copy of the entire Mongo database. You can then use a tool called Mongo Restore. If you want to restore it to your own instance and start poking around, you can do that. Otherwise, this is basically how MongoDump works, but even if you were using a client library, the general gist is that you're going to say, for every database that you're storing on your Mongo instance, how many collections do you have? These are kind of like tables, right? And I'm going to say, for every single one of those collections, I'm going to download the contents of that collection. Let's move on to Memcached. This one's a little bit more tricky. And the reason it's tricky is because Memcached stores data in an interesting way. If you ever look into the internals of how Memcached does what it does, it's interesting. They have to run their own memory allocation. They have to manage their own memory. And so they do it in a way where they set up objects that reference pieces of data in different places. I'm not going to go into the details. We only have 40 minutes, and quite frankly, I'm not an expert on it. But all that being said, all you need to know about is it's not as simple as just hitting it and immediately downloading everything. You have to use some of their special tools that know all the nooks and crannies of how to access the information to Memcached. Fortunately, there is one that was released. It's called Memcached Tool. And it does that by recursively enumerating these places that store data. And Memcached calls them slabs. All you have to know about them is they are placeholders that point to where the data is, right? And this is actually a big point that we need to talk about. Too often we see people roll out these key value storage solutions saying no one can dump the data. I mean, they would have to know the keys, right? They would have to know how to access the data. That's not true. There is a way for me to list out all the keys, and now that I have the keys, I can list out all the values as well. So exposing these key value databases, or the key value solutions, even if they're meant to be temporary data, if you're storing sensitive information in them, it's possible to download that and have that stolen from you. And finally, I have a link to a tool. I'll be releasing these slides, by the way, so I have some links in here. I have a tool from SensePost. It's called GoDerper, and it is basically like Memcached tool. It's another tool you can use to exfiltrate data from Memcached. Now we'll look at Redis. We'll speed through this one since it's really similar to Mongo in terms of there's no real backup solution because it's a key value store. It's meant to hold temporary data. But it has client libraries that you can use to list all your keys and then dump all the values from those keys. Ignore the 3 bullet points. Those are wrong. That's not how Redis stores data. That's what you get whenever you duplicate slides. But Redis kind of sets a tone. And this is how you can expose data for anything. This is what you can start thinking about anytime you encounter a new technology that you want to access data from. Do they have a backup solution? Do they have some kind of a bulk export? If they don't, do they offer client libraries? Then how do I use those libraries to get to the data I care about? If you can put all those together, especially with the client libraries, you can start talking about scanning on a mass scale and getting the data that you care about to do your analysis. And that's exactly what we did. So we decided to look for ourselves. And here's kind of our setup at a 2 million foot view. This is the technical slide. On the left-hand side, we have our technologies. You have Mongo, Elasticsearch, Couchbase, Redis, Cassandra, and Memcached. And we have, you can imagine these being Shodan results because we leveraged Shodan for our analysis, feeding into a crawler that we built. It's kind of Shodan agnostic. It doesn't have to be that, but it's anywhere that you can get results for these services listening on the internet. And then our crawler went out to each one of those instances, and it gathered the metadata that we cared about. Things like, what version are you on? How much free space, if I can tell, how much free space is available? How much data do you have stored in you? And then in certain cases, we would also say, like, let's take Mongo as an example. What are the names of your databases? What are the names of your collection inside of your databases? Dump those out for us as well. And after we had that information about all of these services on the internet, we could then go through and analyze it and kind of pick and choose and sample some of the data because our goal isn't to dump every single database. That's not the intention at all. It's not how we like to do things. So we would sample it and we would say, okay, there's one called examplecorp.users, and it's a huge collection. Let's take the first 2 records and the last 2 records of that, and let's kind of see at least what they're storing to see if it's sensitive or not. If it's sensitive, let's tell them about it, because that's something they probably don't want exposed. This is, from what I could gather, how Chris Vickery did his research exposing all these databases back towards the tail end of 2015. So all that being said, we like to think that, you know, we're past this. It's 2016. There's no way that there could still be a ton of sensitive information, right? Yeah, no, there totally is, though. So as soon as we started scanning, it was clear that this is still a huge problem. You know, we had, right off the bat, the sensitive information started pouring in. Things like session cookies being stored. So these are, you know, if I can take this, plug it in my browser, I'm that user. I have access to the application. We also had OAuth tokens. This was huge. People don't think there's a risk in storing OAuth tokens in their key value stores. Or they don't think there's a risk storing those persistence in Mongo. There is. I can take those and have arbitrary permissions on your social networking site. These are for, whenever I list these details, these aren't for tens of users. These are for hundreds of thousands or millions. You know, so this is a pretty large-scale problem. We also saw the case that we talked about earlier, which was full profile information, so username, password hash, email addresses, security questions. Those were there too. So it's good that you can fall back on those. And then we also had interesting data like location data. There's a lot of apps out there that track where you go every day. So they publish that information up, it's stored, I have a unique identifier for which user it is, and then I have their GPS coordinates for the past 30 days, 60 days, and I can track them over time. I'd consider that to be somewhat sensitive information. And finally, we have detailed device heartbeats. So a lot of devices, especially embedded devices, will ping out to a central server with some information about their state, usage, configuration information. That's where it becomes kind of sensitive, especially if they're exposed externally as well. And we're not done. So we also have what I would call semi-sensitive information. And this is things like, in some examples, we saw cases where there were millions, and in fact, there was one case where it was about 300 million scraped public social networking profiles. So for a large social network, it was a single one. Now it's public information, you know, all that being said, But having 300 million records or scraped profiles in one place is not only a clear sign of abuse by some party, because you can't do that, but it's also, people don't really like having that kind of data aggregated and exposed in that kind of format. It makes it too easy in a lot of cases. We also had a ton of analytics and click tracking logs and web server access logs. So these are, semi-sensitive, but it is what it is. Let's flip the problem on its head, right? If we can see data, maybe we can store data as well. A lot of people talk about exposed data, but they don't talk about exposed free space. My hard drive is already bursting at the seams, so I kind of like the idea of maybe, these servers are out there, they have some memory. How much storage is available? So again, it kind of depends on who you ask, and it depends on when you do your analysis. Shodan came out and just looked at Memcached. This was back on the tail end of 2015, and the author, John Matherly, said there's about 47 petabytes of exposed free space that you can use to store information. Petabytes is a large number. That's a lot of data, right? You're not going to get that with your Amazon Prime photos free that you have. So we decided to do the same test, and we only have 2 technologies because not all technologies expose the available space in their file system through an API. It is what it is, but we ran it through Memcached, and we actually only found 2.1 petabytes, but we also found the number of Memcached instances kind of halved since John's post, so that may have contributed quite a bit. And then we also looked at Elasticsearch, and we found close to 6.6 petabytes of available space. Now, all that being said, let's kind of think, let's think of what we can do with this. Could we theoretically put some kind of a file system layer on top of this that just stores data, our documents and our folders in these exposed technologies, right? Basically making a nice file system for us. And someone definitely already did that. They made a fused file system for Memcached. So if you have a Memcached instance, it only supports one, but you can use it to store the contents of files and directories, and you can navigate it like a standard file system. So imagine what we could do if we took this same concept of storing things in one Memcached instance, and we made it not only distributed, but technology agnostic. What we end up with is like the biggest cloud drive ever, which is amazing. And here's kind of, at a high level what it might look like. Let's say we have our PC, and then we have the software, which would just be called like a fused controller, and it just keeps a mapping of where the exposed instance is. It's constantly scanning. Where are my files stored? We could store our directories in key values because that kind of makes sense. They just have to know, here's a folder, here's where the data is stored. And then you can store your actual documents in somewhere that offers a little bit more persistence. I'm not saying do this because there's so many things wrong with this, but if you think about it, you have a lot of storage and you have great backup options. You don't have to worry about storing things there, right? So there's a lot of benefit to doing something like that. Now let's take a look at the other side of the problem. We've talked about data. Let's talk about systems, right? And here's a claim. There are thousands of systems vulnerable on the internet. And I know what you're thinking, right? Vulnerable systems, who cares? There's nothing new. We've seen some instances like that. But let's talk about what makes these valuable. The first is that they're easy to exploit. We talked about it. This isn't some kind of really complex exploit chain that works sometimes, works not other times. These are exploiting functionality in the software itself that's meant to execute code, and it doesn't restrict it to anybody. So that just gives us full remote code execution on these devices. So they're easy to exploit. That makes them extremely wormable. Since there's no real effort needed. You can script them and automate it really quickly. You also have intentionally beefy machines. As we saw, there's a lot of memory available on these, but they're also meant to be powerful boxes. And the last is that, as we'll see, they're going to be really good entry points into other parts of the network. These usually sit behind your web server, since your web server wants to hit it, and then you also want some of your internal boxes to hit them as well, giving you a great pivot. So here's a claim that there's tons of systems available. This may be a little bit hard to see, but on the left-hand side, the scale goes from 0 to 100,000. So on the left, you'll see Memcached. It's the biggest. It's right around 77,000, followed by Redis, and then Mongo and Elasticsearch, and then you have Couch and Cassandra. So there's a lot of systems available. Let's look at what some of these exploit attempts look like. What are the vulnerabilities that we're talking about, right? So this is Mongo. Admittedly, this is an old one. I don't think I even checked to see how many are still vulnerable to this because it was such an old vulnerability. But it was kind of clever. It leveraged server-side JavaScript injection to gain access to some sensitive parts of code, which let it execute arbitrary commands. I have the blog post on the right. We won't talk too much about this one since it's kind of older, but feel free to go check this one out. It was a great write-up. This is one that I want to talk about a little bit more. I have kind of a history with Elasticsearch. And you'll notice on the right is a blog post that's actually pointing to my personal blog. So full disclosure, this is the other confession that I have to make. The way that I came across this was that I had an Elasticsearch instance exposed to the internet, but it was sitting behind a web server that required basic auth. So I was proxying it to Elasticsearch, not exposing it directly. I only had Elasticsearch listening on localhost, so you couldn't hit it from outside. But whenever I upgraded it, it asked me, do you want to use the new config or do you want to use your config? So me thinking like maybe it's new, maybe like it has features I don't know about, maybe it'll break if I use my own, let's use the new one, I'll go make the changes later. Part of that means that I got their default config which listens on all interfaces. That's problem one. So that exposed my Elasticsearch instance out. About a day later I got a note from DigitalOcean saying, hey, your box was participating in a DDoS attack, we went ahead and shut it down, put it in forensic mode, you're going to have to go pull your files off and wipe the box. So that's really weird. You know, I had Nginx, I had SSH with key-based auth, failed to ban the whole setup, and then I had Elasticsearch. So digging through the logs, I saw some really weird entries that looked like exploit attempts. As soon as you see wget attempt directory, GCC, and weird URLs, you're in for a bad time. And so I started digging and I started looking. Did I miss something? And it turns out this vulnerability wasn't really well advertised. It wasn't made known to a lot of people, just kind of hidden in release notes. And I found a single blog post in a foreign language that was kind of describing the vulnerability with decent detail. So I had to rip apart Elasticsearch, dig through the changes to try to figure out what happened, what's causing this to occur, and having to reverse engineer that vulnerability to figure out what happened to my box. And so I wrote about it there. The important thing to note is that and by the way this one worked is that Elasticsearch thought we should allow people to run arbitrary groovy scripts, which is basically like Java. And they had a sandbox which had a blacklist of things that you could run. And so it was pretty easy to bypass. And that's a pretty nasty design decision since Java's pretty powerful and you can do a lot of things with it, including owning the box. And this wasn't Elasticsearch's first rodeo. In fact, they've had 3 CVEs which all have unauthenticated remote code execution, which at that point is game over to everyone running even the most current version of Elasticsearch out there. And these are actively scanned and exploited. We'll see that here in a second. But the cool thing about Elasticsearch is that there's some case studies where it's really come back to bite some people. It's been the low-hanging fruit. It's been the easy-to-exploit thing in the case of Imager or Imgur, however you choose to pronounce it. Their bug bounty, someone found an exposed Elasticsearch instance, managed that to get credentials, pushed their way into the prod database. The other one was Inversoft's Hack This. It was a company who put out here's how to set up a secure server. You should set it up in this way. We'll give you a MacBook if you can break in. And so what someone did instead was they went after the company's infrastructure, found an exposed Elasticsearch instance, popped that box, used that to gain access to another system, which gave them I think they were using Linode, gave them the creds to go into the actual panel that was running their secure server and extract out that information. They got the MacBook. So we talk about it being actively scanned and exploited. This is an example, and this is where Elastic Honey comes into play. As soon as I found out what was going on, I built this honeypot to measure how much this is being exploited, and it turned out it was quite a bit. There were a lot of actors trying to exploit the device, download generic malware that communicates back to a CNC. It's just your standard IRC kind of stuff. But they had tens of thousands, if not hundreds of thousands of nodes actively reporting to them at any given time. This is because no one really knew to upgrade. It wasn't really made known that this is an issue. And moving forward, we actually we did some interesting work with Redis recently. We talk about key value stores storing data in memory, right? But Redis also stores it on disk, and that's kind of advertised for persistence. There's a problem with this whenever people decide to run Redis as root, which they do a lot, because then I can also remotely configure Redis using its API. I can tell it, here's where I want you to store your copy of the database on disk. And so what I'm going to do as an attacker, and there's kind of some irony because the person who came up with this attack wrote Redis, and so they published this blog post saying, here's how you could hack Redis, and someone promptly made it into a worm and owned all these Redis boxes. But what they said is you could store it in the authorized keys file for the root user. If I'm running as root, I have permission to write there. And SSH, whenever accepting an inbound connection, it ignores any garbage that's left over. So what I'll do is I'll set a key, and the value of it is going to be my public key. And so then I have access to the host. I can just SSH to it at that point and do whatever I want, because Redis wrote my public key to the authorized keys file, and so SSH is going to honor it whenever I try to hop onto the box. And that gives you remote code execution. So what we found is that it was kind of an interesting case. People were breaking into Redis boxes, and then they were doing what I call fake ransomware, which means they deleted a whole bunch of files and left a ransom note saying, if you want your files back, you have to pay us this money, and then we've encrypted them and sent them onto our own secure servers for storage. We'll give them back to you after you pay the money in Bitcoin. The key is that if you're a victim, you don't know that they were deleted. You think, in your mind, if you don't have a backup, you have no other option than to say, maybe they really did take the files. I really don't know, because chances are they're not going to have a PCAP running on that server to see what's going on. Fortunately, we did. We made a honeypot again. That's kind of my thing. I kind of like doing that. And we saw the attackers coming in. We recorded the whole session, and they were just deleting the files. They were RM, RFing entire directories, and then dropping the ransom note. This one's fun. This was actually kind of good timing for me, but crappy timing for everyone who has a Memcached instance. 2 days ago, I was going to come up here and say, Memcached actually has a really good track record, and it does. As we'll see, people haven't really had a need to upgrade Memcached until today. In which case, if you have one, stop listening, go upgrade your Memcached instance, because Cisco's Talos team released multiple integer overflow vulnerabilities which can be exploited to get remote code execution. So you just have to fiddle with the memory a little bit. It's exploit math that's above my head. But all that being said, this is a perfect example and a great thing to look out for, because this will be weaponized. We talked about Memcached being the #1 software that we're seeing out there with close to 77,000 exposed instances. As soon as someone releases a weaponized proof of concept, it's going to be a bad day. Now, Cisco already released proof of concepts that I can confirm. I tested them myself. They dropped the box. They segfault it. It's not meant to run a command. It's just meant to show you, hey, this exists, and it'll crash your server. So if people really wanted to, they could just go and drop every Memcached instance out there because the code already exists. So all that being said, let's take a look at the landscape. What did we find? So here's Redis. You may not always be able to see the vulnerable versions, but I have them down at the bottom, kind of grouped by major release. So Redis, whenever they figured out that they listen on all interfaces, that people run it as root, and that they don't put authentication in front of it, and people are having a problem, they put in something called protected mode. This is just where if it sees all three of those, it immediately drops you down to localhost only until you set a specific flag that says, I really want to get owned. Right? So that's whenever protected mode came out. Let's see who all has that as an option. So all of those do not have that as an option. And a majority of those are going to be running as root and are already owned. Let's talk about Elasticsearch. This is actually a pretty good story. It's not as bad because the vulnerable versions aren't, it's not as much. People are actually upgrading Elasticsearch much better now after the first two initial remote code execution vulnerabilities came out. And finally, let's look at Memcached. This is kind of fun. Before we talk about how many are vulnerable, because I'm sure you can guess, let's look at what the landscape looks like now. These are the years, you don't have to even know the version numbers, these are the years that they came out. And so you'll see the top 2 came out in 2009, 7 years ago. People haven't really needed to upgrade them because in the past there's never really been an urgent need to do that. Sure, there's performance improvements, there's functionality, but who cares about that? It works, right? So in terms of being vulnerable, all of them. Every single version that you see is included in the one that's vulnerable to remote code execution. So I can't stress this enough, keep on the lookout. And that's 3 examples. We didn't want to go into all of them. Cassandra also had one because it allowed for system commands to be sent over their API, listen on all interfaces, and they're unauthenticated. So what's the root cause, right? Why does this happen? And we'll kind of move forward in the interest of time, but in a nutshell, we've talked about it. Default configs listen everywhere. There is no authentication being configured. Some support it, but they're not configured. The software is still kind of new. It's lacking a little bit of that maturity that it is gaining over time. And at the end of the day, whenever you follow the quick start, it works. It just works. It does what the business needs. The security section is always at the bottom after the quick start. So many people probably don't get there, and they just leave their box open. Now, it's important to know that things are getting better. We've talked about, things are burning, there's a big problem. But in the grand scheme of things are getting better. We are seeing the number of available instances go down. And this isn't like the scale of, let's just call it like Internet of Things, right, which is a catastrophic train wreck happening in slow motion all around us. This isn't as bad, right? And people are starting to wise up. These breaches and these exposed data are wising people up to, I should review if my data is exposed. So we're seeing things improve. We're also seeing it in the software itself. Like I mentioned, Redis has a protected mode. We're also seeing default configs start to listen on localhost, which is a huge improvement because by default now everyone can't get to it. Large data breaches are being cleaned up and software is becoming more mature. So let's talk about how to protect yourself. In a nutshell, it comes down to basic security hygiene. All those things that we talked about, just make sure that you're not doing that. Make sure that if you don't need your data exposed externally, don't make it exposed externally. A lot of these technologies have authentication in front of them. Use the authentication in front of them. Find their security best practices and run through that list and make sure that you're doing that and constantly check for new additions as they come out and upgrade your software. If you want to do any kind of future work, Shodan has a nice page where they list their searches right there for you. You don't have to know the syntax. You can just click the button. And finally, I include some helpful resources. So these are links to the security best practices for each of those products. If any of those are being used by your organization, feel free to poke through those. So see that right on time. Let's open up the floor. What questions do you have? Thank you all for coming to the talk, by the way.